This is homework from 7.2a. This is over disk method, volume by disk method. Let's start off looking at number 7. It says revolve the region about the y-axis. So the region is provided for us. It is the equation y equals x squared, only in the first quadrant. Here's our y-axis. I put a dotted line there, so think of that as the center of this object. And we're revolving this shaded region about this vertical line. Next, we want to draw our radius. So starting on the axis, you're going to draw to the graph or to the curve, and you see that the radius that you drew is horizontal, which means that we're going to be using the right minus left method, meaning everything has to be in terms of y. So this equation, we have to make some adjustment. Y equals x squared. If we solve for x, x is equal to square root of y. Next, we want to find what r of y is equal to. So we look at this horizontal rectangle, determine that the right endpoint is touching the x equals root y. So square root of y will be the right graph. And the left, we look at the left endpoint of the rectangle, and it is right on the axis at x equals 0. So 0 will be the left graph. So we have square root of y minus 0, which is square root of y. And our bounds, we can tell, is the lowest y value to the highest y value. So the lowest y value is 0, the highest y value is 4. So then we plug into our formula. Volume is equal to pi radius squared. So our radius is square root of y squared dy. Bounds from 0 to 4. So we can go through a power rule, but first we can simplify this to simply be y, because the square root and square cancels out. So a power rule from here, we get y squared over 2, plug in upper bound and lower bound. So plug in 4, we get 16 over 2, which is 8, minus 0. So we get 8 pi cubic units. All right, number 9, we have our shaded region. Given by the line y equals x to the 2/3, the horizontal line y equals 1, and the vertical line x equals 0. So in this shaded region here, we see that x equals 0 is, or the y-axis is our axis of revolution. We're going to be rotating this about the line. So for rotating this object, this shaded region about this given line. And if we want to draw our radius, we start on the axis and we draw to the graph, to the curve, and we see it's a horizontal axis, horizontal radius, meaning everything, just like number 7, we'll be using right minus left method. Everything has to be in terms of y. So if that's the case, we have to look at this equation and we have to make some adjustments. If I solve for x, I'm going to raise both sides to the reciprocal of this exponent. So we get x is equal to y to the 3/2. And if we want to find r of y, okay, that's simply going to be the right endpoint minus the left. So if we look at the right endpoint of this rectangle radius, it is on the y to the 3/2. So this is my right graph. Okay. Minus my left graph. My left graph will be x equals 0 because that is where the radius, the left endpoint of the radius is hitting. Okay. So then right graph minus left, this will simplify to be y to the 3/2. So then we plug this in our formula. So y to the 3/2 squared is simply y cubed. Go through power rule. And before I forget, the bounds are from 0 to 1 because we're looking at y value. So we have to go from the lowest y value, which is 0, to the highest y value, which is 1, because we're stacking these horizontal disks from 0 all the way up to 1. Okay. Once you go through power rule, y cubed becomes y to the 4th over 4. Plug in 1 in for upper bound, then plug in 0. We get 1/4. Don't forget the pi. So then we get pi over 4 cubic units. Okay, 23. Find the volume of the solid revolved about the x-axis. So we have 4 lines or equations that we have to account for. So y equals 1 over square root of x plus 1, that's this curve here. Y equals 0, that's this line here. X equals 0, that is the y-axis. And x equals 3, given by this line here, vertical line. And another, just want to stress this again, all these lines and graphs have to contribute as boundaries for the enclosed region. Okay? Sometimes the challenge is deciding where the enclosed region is. So once you shade your region, make sure that your shaded region has these lines and graphs contributing as a portion of your shaded region, as boundaries for your shaded region. Okay. Our axis of revolution is the x-axis, so I have a dashed line here with this notation to indicate that this is the center of this object, and we're going to be rotating this shaded region about the x-axis. So we start on the axis, and we draw to the graph, to the curve, and then we see we drew a vertical rectangle. Vertical radius means that everything will be, we have to use the top-bottom method. Everything is in terms of x. Okay, so we look at this rectangle here. Top of the radius is hitting the 1 over square root of x plus 1, so that's my top graph. Bottom of this radius is hitting the y equals 0 graph. So then we subtract that. Top graph minus bottom graph, which is 1 over square root of x plus 1. Plug into our formula, pi r squared, from 0 to 3, okay, because everything's in terms of x, so we're looking at the left bound is 0 and the right bound is 3. The square root will cancel out once we square that, so simply 1 over x plus 1. We can go through u substitution. U is x plus 1. Derivative is 1, dx equals du. Now this matches up nicely with the natural log rule with the integral of 1 over u to the first power du, which is natural log of u. Plug in the upper bound, so ln of 4 is ln of 4 minus ln of 1. And we do have to make some adjustments. I forgot to say that because we're going through u substitution, our initial bounds from 0 to 3 are going to change because now we have to convert our x values to be in terms of u. So plug 0 in for x, and we get 0 plus 1, which is 1. Plug in 3 in for x, we get 3 plus 1, which is 4, so that's why our bounds change from 1 to 4. And then we get natural log of 4 minus natural log of 1. Natural log of 1 is 0, so simply pi times natural log of 4, and we can plug that in our calculator, which is 4.355. Okay. Let's look at a few more problems here. Okay, so 25 from 7.2, we have y equals 1 over x, y equals 0, x equals 1, and x equals 4, revolved about the x-axis. So again, we have our graph, our y equals 0, x equals 1, x equals 4. These, we have the shaded region here. Notice that the shaded region has portions of the lines and graph contributing to the boundaries. We have the x-axis being the axis of revolution. This is the center of our graph. So we start on the x-axis, start on the axis of revolution, draw to the graph, and then we determine these are vertical radius, so we do top minus bottom. Top of this radius is hitting the 1 over x graph. Bottom of this radius is hitting the 0 graph, so 1 over x minus 0, which is 1 over x. And our bounds are from 1 to 4. Okay. So pi r squared, don't forget that squared there. So 1 over x squared, we have to go through power rule, rewrite it as x to the negative 2. Okay. Power rule requires our variable to be sitting up in the numerator. Go through power rule, we get x to the negative 1 over negative 1. Plug in upper bound and lower bound, so we get negative 1/4 plus 1, which is 3/4. So therefore, our volume is 3/4 pi cubic units.